How you doing, guys? Welcome back for another video. This is going to be our last lesson for domain and range with quadratic functions. All right, so let's go ahead and get into it today. All right, so first of all, we're going to label what our coefficients and features are for each quadratic equation. And so, yeah, as you can see, I have my handy dandy decimals here to help us out. All right, so let's go ahead and start with our first equation. Our first equation is y equals to x squared plus 8x plus 7. And so we're going to put that in invisible 1. So our a is 1, our b is 8, and our c is a 7. So if it's going to curve up or down, the trick is when A is positive, it's going to curve up. But I don't want you to take my word for it. Let's look at a visual. We have y equals to x squared plus 8x plus 7. So as you can see, it's going to curve upwards. So we're just going to check off the box that this one is curving upwards. Okay, in the second example, our A is 1. Okay, because A is going to be with an x squared. Our B is a 2. And in this case, we don't have a C. So we're going to put 0 in there for C, as if we were doing a plus 0, because anything adding 0 is just nothing. Now, because, excuse me, my A is -1, sorry. Because my A is negative, it is going to curve down. But don't take my word for it. We have negative x squared. In this case, we have plus 2x. And if you want to, we can put the plus 0. But if you don't, it doesn't make a difference. And as you can see, this is curving down. So without even using our decimals, we're going to look at our A. My A is a 1. B is -2. And C is -8. Because A is positive, I know this is going to curve up. A is -5. B is 10. C is 15. And because my A is negative, I'm going to be curving down. All right. So now we have learned how to label the coefficients from our quadratic equation, similar to what we've already learned in the past, our A, B, and our C, and how to describe if it's going to curve up or curve down based on their feature. Let's look at another example. Okay, so this is super important that we're using those key features that we learned before to help guide us. So we need to match each quadratic with the equation. We can't always just go off looks. We have to actually make sure that everything is matching up completely. So as you can see, in each equation here, our vertexes are all different. In our first equation, our vertex, which is in the middle of the quadratic, is at 1, -9. And so if I was looking at my graphs here, I can see that answer choice C, and I'll zoom in here on the graph, that answer choice C is at 1, -9. So if I had to do this, I would definitely say that this C goes with our first equation. All right. Let's look at our second equation. Again, I can already tell that because my A is negative, that means I have two answer choices that it would be. It's either going to be answer choice A or answer choice C. I'm going to go ahead and cancel out answer choice C because we've already identified that one. So that lets me know that this equation right here, because my A is already positive, that D would go with this equation. Okay, so I'm just looking here at my A, the same information we learned before. When A is positive, I'm going to have a curved up line or a quadratic. And if A is negative, I'm going to have a down curve or curve down. So let's look at our second equation here. It says -x squared plus 2x. So I'm just going to change this to a plus, get rid of this -8. So my vertex for this one is at 1, 1. If I looked at my two options, 1, 1's vertex is answer choice B. So for this equation, I'm going to say this one is B, matches with B, and this one matches with A. Gotta love decimals. All right, so we have successfully matched each quadratic graph to its equation. All right, last example of the day. And it's pretty simple. We're going to talk about our domain and our range. Okay, so I'm going to tell you right now, because we're going to have some arrows, our domain is automatically going to be those all real numbers. So we can already just say this is going to be all real numbers, all right? So anytime we have a equation, most times the domain is going to be real numbers. So we have y equals 2x squared plus 4x minus 3. Now, the way we know what our range is, and I'm going to go ahead and just draw our sketch here. Just like this, and I can already tell that my y is going to be greater than or equal to, because it's curving up. Because it's curving up. Now, to know how much, I'm going to look at the vertex. So on my notes here, on my vertex is at -1, -5. Well, which number do we pay attention to? Because they gave us two numbers here. Well, that's super easy. Remember, the range is the y values. So we're going to look at the y value here, and our y value is -5. So our range is y is going to be greater than or equal to -5. And that's because all of these y values, like 5, for example, is greater than -5. Or it can also be equal to, because it's included. That's super important. Let's look at the next one. Again, because we're going to have arrows that's going to be continuing on and on and on. And what do I mean by that? Let's look at our first example. If I zoom out, it's going to keep going on forever and ever and ever. And that's how come the domain is always going to be all real numbers, no matter what, most times, unless they give us a graph with conditions or a situation with conditions where we start and we finish somewhere. So let's look at our second equation. The second equation is -x squared plus 2x plus 3. Oops, plus 3. So as we can see, this is going downwards, meaning that I'm going to have a less than symbol because everything is less than. So less than or equal to, because it's included. So if I draw my sketch of my graph, and again, it does not have to be perfect. I'm going to go ahead and draw my arrows too. I can already see the vertex is somewhere. Vertex is somewhere right here. And the vertex says, let's go to our tools, is at 1, 4. So I'm going to write here 1, 4. And of course, we know the range is our y value. So that means that we're going to have y is less than or equal to +4. Okay. I hope you guys enjoyed this lesson today. It's the last one for domain and range of quadratics. Congratulations. I'll see you guys the next time.